Hello, how's it going, everybody? Oh, wonderful. Looks like everything is working. Sorry for the delay, folks. Just getting a few things sorted. Let's see here. I say that as the screen goes to black. Let's see if Kerbal Space Program will load in a window. Oh boy, that's fun. Let's give it one more try. Window capture. Well, I tell you what, the stream does not like the idea of recording this at all. So we're just going to hack it, and hopefully I don't make a fool of myself. And we're going to do a display capture. And we'll fix it this way. We're doing it live, folks, so forgive the... There we go. That should have fixed it. How's that looking? All right, awesome. That only took 5 minutes. How's everyone doing tonight? Looks like we have the usual suspects. Thank you all for joining me. I am just very excited to be here. Kind of a cool thing happening today. The 10,000 subscriber mark. Which I think means we should play some Kerbal Space Program. And supposedly this, we should have some spacecraft already going. This is a career mode playthrough that I haven't been to in a long time, so I don't know what we're supposed to be doing. So let's go check and see what missions we have accepted. We have no active missions. So let's see. We can plant a flag on the Mun, position a sensitron in an adjusted orbit of Kerbin, science data from the Mun, explore the Mun. This is feeling like we should go explore the Mun. Is anyone else getting that vibe that the game is saying, go explore the Moon? Oh, and it crashes. Fun. Fun. Let's not do that. That's okay. This will be a quick fix. It's nice to have a computer that is actually not stressing to play this game for a change. When you first started playing Kerbal Space Program, every computer kind of just struggled to even open the game. Window capture. There we go. Do 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 do. All right. Breaking ground, changing batteries, waking the Kraken. So what is everyone else doing this evening? I was this evening going to be working on my solid rocket motor, but circumstances intervened, and I am not doing that now. Instead, I am streaming Kerbal Space Program because that's fun. What a great way to spend an evening. There we go. You know, Joe, I think I will defer to you on any musical talent required. All right, so let's see. How many contracts can we take? We can take... let's take this one. Sensor data from surface of the Mun. Let's take that one. Explore the Mun. We'll take that one. I think that's all of the Mun-related contracts. This one says a new uncrewed probe that has an antenna and can generate power, orbit the Mun, have a mystery goo unit, have a orbital telescope, and maintain stability for 10 seconds. And this is maybe a thing we could do on our way. We could like bring along a spare spacecraft, so we'll do that, and we'll find out how bad of an idea that contract was in a second. Ooh, we have some excellent responses. Nurka, I'm not sure how to say the first word of your name, Nurka, but is working on injector designs for your team. Which ones are you considering? What are good programs for finding propellant characteristics? Caleb, if you find one, I have a PhD and a job for you. For solid rocket propellants, you basically just have to build them and try them. If you're talking about liquid rocket propellants, though, you could use either RPA or CEA. CEA is NASA software that's free, and RPA is software that you can use for free, but really wants you to buy a license. Oh, it's still showing you guys the loading screen. That is not helpful. Let's, weird. I wonder why it's doing that. All right, well, we'll try one more time. Window capture, KSP. This is not the first time it has done this to me, and I wish I knew... Oh, wow, okay, so it's still so when I try and show you guys the real screen again, it shows the loading screen. I don't know why that is. We can fix that, though. Again. There we go. That's more or less fixed. CEA is a web program, I think. I don't know if there's a downloadable version for it, Saturn. All right, I think we got this now. So we've accepted a bunch of contracts, and I'm sorry you guys couldn't see them, but the contracts we accepted were plant a flag on the Mun, collect science data from the Mun, explore the Mun, and return to Kerbin from the surface of the Mun, and position a satellite around the Mun. So we've got a healthy list of things we need to be doing. So we'll do, let's do a good old-fashioned Apollo-style Munner exploration program. So we can do coupling. We haven't researched docking yet. Do we have enough science to get docking? Yeah, Joe, it's weird because it's so true. The window capture just does not play nice, but the display capture works fine, um, which is just what I did. It would have been clever if I'd prepared that beforehand, but we try our best. Okay, so I think this is docking here. Does this have docking ports? No. Which one of these is docking? Space exploration? No. Miniaturization. This has a docking port. Does this have the big docking ports? Not that one. Nope. Nope. Specialized construction. Clampotron docking port. We want this one. So we need 17 more science. So let's just real quick actually put together a rover. Hey, Dr. B, welcome to the stream. Paulo Duarte. Here in Brazil, there is one startup working with hybrids. They say it's simpler and safer than liquids. They are wrong. It's subjectively true. They are wrong. If someone says that hybrids are better than liquids or solids, they don't know what they're talking about because they're wrong. Because hybrids are objectively evil. Hybrids are just horrible. Don't use hybrids. Get some help. Don't use hybrids. Okay. So, let's see. We're just gonna put together like a real quick and janky spacecraft with some science equipment, and we're gonna launch it towards the mountains, get 17 science, research docking ports, and then go to the moon. That's what the plan is. So now we've got a parachute on this, so we needed a decoupler. Boom. All right, decoupler. Now we need a solid rocket motor. A big one. Maybe bigger than that one. There we go. Awesome. Science. And then we want some science experiments. Those are lights. Science. What do we want to put on this? We can put a mystery goo, a thermometer, a barometer. Do any of the other of these work on the ground? I think the answer is going to be a no. Yeah, it needs to be up in the air. All right, so we'll just do this, and then now we need to get this widget kind of back towards the mountains. So we'll just kind of do one of these numbers. Oh, and it needs fins, otherwise this is going to end badly. 2, 3. Ooh, control R. 2, 3. There we go. That's what I wanted. So if you do control R, it lets you switch between symmetry modes in the assembly buildings. So we've got just kind of the dumbest, most simple, light the solid, launch the thing, separate, deploy the parachute. And we want actually, I think, a scientist, not Jebediah. We'll get Bill. All right. What could possibly go wrong on this contraption? All right. Nurka, you're looking at impinging versus pintle for a 1,000-pound thrust Ethalox engine. You only have a 4-axis CNC, so impinging would be kind of difficult to manufacture, whereas pintle would be harder to design. Nurka, I think pintles are pretty easy to design, to be honest. I spent maybe 4 hours on my pintle design and was very happy with where I got it. I do kind of have some experience with pintles, so it wasn't that out of the ordinary for me, but certainly I think you could make pintles work. I would certainly pick a pintle in that situation. Caleb, what about Virgin Galactic? I support all aerospace companies. I love all of my friends, and I do have many friends working at Virgin Galactic. We're going to launch this rocket. We're going to come back to this conversation. All right, I need a countdown. 5, 4, 3, 2, 1. Ignition. Uh-oh, this might go badly. I'm starting to think that there may have been a better idea than what we're doing here. Because I don't think we're going to have an opportunity to deploy the parachute before we smash into the ground. I regret this decision. We may survive this mistake. There we go. I think I fixed the staging screen for everyone so you can see it now. Parachutes. Okay, we are going to survive this mistake. There were definitely some mistakes made in that process. Better choices could have been made. But we will take a crew report and keep that. 3.5 science. We need 17 science. All we need is 17 science. Okay, so like I was saying, as we watch Bob Kerman descend under parachute, I really don't mean to speak. I do mean to speak ill of some decisions, but I don't want to like have this construed as blame. I think that hybrids are an objectively more dangerous choice. Nitrous oxide is a hazardous propellant to work with, and I think it's more hazardous than LOX. It's no mistake that the fatalities that have occurred in the United States commercial space program have occurred on hybrid programs. No one has died working on either solid rocket motors or liquid rocket engines in the U.S. space program, commercial space program. But, Virgin Galactic has had 2 fatal accidents just in the last 10 years. So I really do think it kind of, says something about the safety of the program that they are having those accidents, and it concerns me. It concerns me that was considered to be a valid and safe approach that then yielded such, results. But we can take some data here real quick, and we can take an EVA report from you. Surface sample. We'll keep that. We'll get... Whoop, I don't know what happened there. All right, and we should be able to take another crew report. Landed at Kerbin's glass lens. Okay, well, we've already got that one, apparently. So we should just be able to recover now and get enough science to buy the docking ports. Saturn, you notice I carefully caveated that as commercial space program. The Saturn one was U.S. government organization, and also Challenger and Columbia were fatal accidents. Saturn Spaceship 2 is a hybrid, which is why I suspect that it validates my argument that hybrids are hazardous. Caleb, it was a mistimed application of the feathering safety lever by one of the pilots. Was the accident in 2014. The accident in 2009, and I believe there was one second accident, were both on the test stand, and they were results of the hybrid motor testing. All right, so we've got the docking ports. Now we can go build our spacecraft to go explore the Mun. Ryan, do I ever tire of talking shop? No, I really don't. I put in my 10 to 12 hours a day of rocket science for my employer, And then I come home and I work on rocket engines for YouTube. Actually, if we're feeling inspired, I may go get my solid rocket motor I was working on for. I was gonna test fire my solid rocket motor for a 10,000 subscriber special, but and bless him, Tim Dodd plugged me on the stream he did today, and I went from 9,600 subscribers and well over 8 days to finish my solid rocket motor project to 10,000 subscribers kind of in 30 minutes. So that didn't happen, but it was nice of him to do so. So here we go. Propellant tanks. This is going to be our to the moon and back propellant. Engines. There we go. So now below this, we need to put a lunar lander of some description. And you don't need the shroud. Yeah, shroud off. All right, so we want to put a lunar lander. So the first thing we're going to want is a docking port. And then we need a command module. And our options are this one or this one. What's the difference? This one has 2 pilots. Oh, you have to have 2 pilots. Okay. It has a science experiment. It can collect crew reports. It has some liquid fuel and some monopropellant. Oh, and some oxidizer. Okay, so this is super useful. So we want to do like a real Apollo style model. This weighs 2 tons and this weighs 0.66 tons. Oh, but this one has the fuel. Okay, so we're doing this. Oh wow, that is the wrong size docking port. You know what? We'll live with it. Unfortunate, but it's what it's gonna have to be. So now we need the engine for this thing, which I think we use. No, that's not the engine it wants. It's gonna want the spark engine, I think. Yeah, this one. But like, truss mount, and I think we want it to go. Nope, didn't like that. Okay. How does this work? I know this works. There we go. Okay, so we've got that. So then we add the decoupler right there. Yeah, no, we want this decoupler, I think. And then we want to add a big fuel tank. Maybe actually a little fuel tank. No, not that one. Yeah, here we go. 1. And then we'll just do an array of these. Cool. Let's, can we turn off that shroud? RCS. No, okay, so we can't turn off the shroud, unfortunately. That's okay. It'll work fine. What we'll do is we'll hack it a little bit and see how much further out we can get them. There we go. Okay. And then we'll add some struts to make it look cool. There we go. See, what a cool looking lander. And then we need an engine. We'll use a Terrier. And we will go ahead and do that. And then it needs some legs. Okay, back to the chat. Thoughts on the Rocket Lab failure? Oh man, that's that's rough, man. I feel for Mr. Beck and the whole team. I've got friends at Rocket Labs, and you never want to see anyone fail. But that's a rough one. They were in the groove, and this kind of thing happens where eventually you just kind of find the esoteric failures. Um, Saturn, how you ever made a liquid engine? The very first liquid engine I made was with the help of a grad student at MIT who showed me the ropes and probably saved my life a couple of times. And then after that, I just kind of kept doing things and eventually got better at it. Heat shield, that is a great idea. Let's fix that right now before I forget. Thermal heat shield 2.5. Boom. New heat shield. Okay. I think. All right, so we need legs. Here we go. This has got some leg options. I think we're just going to go with 6 of these spidery looking widgets. That doesn't actually reach the ground, so we want to lower those. Now they're below the capsule, which is good. Sorry, below the engine bell, which is good. And then we'll extend them in a little bit. There we go. And then we should be able to start retracted. There we go. Oh, that looks awesome. Check that out. That's so cool. All right, let's add some lights real quick because I always forget lights. Would that be under electrical? We do need to add some solar panels. We'll just add 2 and... And we're going to need to add some solar panels to this. Okay. Lights. We were looking for lights. I may not have unlocked all the lights we need yet, so there may not be lights happening on this one. Oh, here's some lights. I don't know why they're here and not under, like, the lights, but that's okay. We'll just add 2. 1 and 2. And we'll give them a little bit of tilt just so that they point better. No, come on. Yeah, there we go. That'll play. Okay, there we go. So this is, I think, the lunar lander done, unless I've forgotten anything significant. Ian wants to know what my thoughts are on cold gas versus monopropellant. What a pertinent question. I am actually working on one of both systems right now. Let me tread carefully here before I say something I shouldn't. I'm waiting for the chat to explode on me, but let's see. So I think I can show the RCS system, because the RCS system is for a cool project I'm working on. Let's see. Here we go. Can you guys see this? Yeah, you can. All right, awesome. So this is the RCS system I'm working on. It's for 4-inch high-powered rockets. This is a 48 cubic inch paintball tank. These are fairly cheap Chinese solenoid valves. I think each of these is like $16. And then there's a paintball regulator that goes here, and then a welded line that goes between this fitting and the paintball regulator. And so this whole setup, this is $50. The regulator's $90. That's $140 plus $80. So the whole thing's like $250. So it'll be a very cheap RCS system, so I can afford to crash it a bunch of times while I figure it out. So I'm working on this one, and this is okay. The response time on these valves is great. Each of these is a 15 Newton thruster when I install the nozzle on it. But, the downside of the system is that the ISP is like 60 seconds, whereas like a monopropellant, you can get a couple hundred seconds on a monopropellant thruster. Maybe if you're really lucky, you can get 300 seconds ISP. I say lucky. I mean, if you work really hard and design a really good thruster, you can get maybe 300 seconds. So obviously you need a lot less propellant, but it comes at the cost of complexity. So I would say if you're trying to fly a space mission where you're talking about you need years of propellant, do monopropellant. But if you're just launching some derpy sounding rocket, you can afford to get away with cold gas. This does not need a shroud. All right, we are going to be here all day if we don't finish up. So let's. Oh man, that's great. Check it out. The whole thing fits in a 2.5 meter. Nice. Okay, so now let's set this up to do 3 clamshell, no interstage nodes. Awesome. Okay, I love it. Check it out. And then we can turn it off so that it doesn't automatically open. Oh no, that might just be in the new version. Yeah, okay. So we can't lock the fairing quite yet, but that's cool. And we should... No, this is cooler. Okay, we'll leave it like that. So now we need to add the... Where was it? We need to add the escape tower, obviously. 2 parachutes and a drogue. 1, 2, and a drogue. And then I need to find the... There it is, the escape tower. Boom. Okay, awesome. Cool, so the rocket is starting to take shape. Now we just need to get all of this towards the mun. So we'll add a big upper stage. Not that one. Oh, I don't have 3-meter parts yet, do I? No, I do not. Okay, this is going to be a... It's going to be an experience here. Okay, all right, we'll see. We'll see how this goes. So we'll do 2 of those, and then we'll do lots of engines. I don't have any mainsails yet. Okay. All right, we're figuring this out on the fly. We are improvising in real time. So I just need everyone to stick with me here. So Jeff Reich wants to know what I'll do next year. And to be honest, I already know what I'll be doing next year, probably. I am gainfully employed at a full-time job as a engineer on a rocket program for a company called Agile Space Industries. I am the lead developing a new kind of rocket thruster that I can't tell you about, but it's really cool, and I look forward to when I can show you what I'm working on in my day job. Paulo wants to know if you should distill your own peroxide, to which the answer is categorically no. People who want to use peroxide should either be able to buy it, or your rocket hobby will become a peroxide brewing hobby. Lucas says, I arrived at your channel today from the Everyday Astronaut video and immediately subscribed. Great content. Thank you, Lucas. I really appreciated that. Adam, why would you use RCS in space when you can use gyros? Because sometimes your gyros saturate. That is, they run out of spare material. They run out of spare inertia to provide. And when that happens, you need to desaturate the wheels by spinning them down. And to do that, you need to transfer that momentum away from the spacecraft. And the only way you can do that is by exhausting propellant. Okay. Let's figure out how we're going to do these structural... Okay, that's not what I want. I want like an engine plate And I don't think I've unlocked them yet. So if I can't have a clamping, if I can't have one of those, maybe what I can do is I can take one of these fuel tanks. Yeah, here we go. We're going to hack together a plate. Oh, these are for 1.8 meter engines. No, I don't want that. I want 1.25 meter engines. Oh, yeah, so we want an FLT. FLT 200. Here we go. I kind of want an FLT 100, but given that I don't have one of those, we'll make do. Okay, so there's that. And now we need to put some aerodynamic caps on that just so it looks good. But like the right sized aerodynamic caps. There we go. And some fuel lines just to make it work. Cool. All right, so now let's do a quick check on the thrust to weight ratio. No, not that. So if I click there, it'll tell me that the TWR is 0.6 at ground level, which obviously is not going to work. So that means we need boosters. And I think the boosters can really just be this easy, where we get some of these radial decouplers. This is like the international MUN landing because you've got like this like very Saturn upper bit and then this very Soyuz first stage. Engines, and we'll just slap these on. Nope. We'll just slap these on. Excellent. Okay, so with that out of the way, we don't want to do asparagus staging because we want to burn propellant on this inner tank so we can be lighter when we stage off. So let's go ahead and check. So we've got, all right, checking our staging, because you always want to check your staging. So we light all these engines, we get 800 meters a second with the thrust to weight ratio off the pad of 1.5. And then we stage off these side boosters, and we have a thrust to weight ratio of 0.66 with a burn time of 203 seconds and an ISP of 1,880 meters a second. So this will get us into orbit. What is this? That's that engine, and then that's that engine, and then that's that engine. So if we swap these now to show vacuum ISPs, we get 240 meters a second with this stage here. Oh, because I haven't set up. All right, let's fix that now. So I need to add the external fuel ducts from there to there, but that didn't work. Let's try that again. External fuel ducts from there to there. Okay. It still thinks that it only has 240 meters a second. Oh, right, because it thinks that it's landing with the command module on top, which it's not. All right, so we're fine there. 68 meters a second there, also fine, because it still thinks it's landing with the command module on top. Then this has the RCS thrusters, so now this needs RCS thrusters here to do the transposition and docking. So 1, 2, 3, and 4. And then we need to add just a little. You know what? Well done, Charlie. Well done. That was always destined to happen, wasn't it? I just spilled my Shirley Temple all over my carpet. All right, 1 second. All right, we're back. My carpet will be cherry colored for the rest of time, but other than that, situation nominal. And I'm taking this opportunity to switch to Blue Moon. Should be tasty. And it's on brand because guess where we're going right now? The moon. Ian Ross with the new carpet fund. All right. Well, luckily, I think cherry-colored carpet is not the worst of crimes that has ever been committed by humanity. All right. So let's get this rocket ready to go. So we need to set up some action groups. And you know what I'm going to do? No, I'm not going to do that. I changed my mind. All right, we need to set up some action groups. So action group, the first one we need to set up is the abort action group, which will decouple that, activate that, and we want to... All right, I think that's all we need to do there. So then custom one is going to be decouple node, activate engine. All right, I think that's what we needed to set up as far as action groups go. All right, now we need to check for science experiments. So let's check our contracts. All right, so we need to plant a flag on the Mun. We know we can do that. We need to transmit or recover scientific data from the surface of the Mun. We know we can do that. We need to rendezvous 2 vessels in orbit of the Mun. We will be doing that on ascent. Return to Kerbin from the surface of the Mun. We will be doing that upon ascent. Build a new uncrewed probe that has an antenna and can generate power. So we need to bring along a probe to fulfill these requirements. And we're gonna hide it like here. There we go. Let's see, it needs to be able to generate power and have an antenna. Oh, we need an antenna. Let's do that before I forget. We'll use this high gain antenna and just throw it right there. And we'll put one of these antennas on the lunar lander. Oh, but it needs to go on the ascent module, so we'll do that. All right, so it needs to probably have a small monopropellant tank. Not that one. Ooh. I think the Shirley Temple is now getting in my printer. That's unfortunate. All right, so we've got that, and now it needs a probe core. So probe core, engine. Do I have a monopropellant engine yet? I do not. That's okay. We'll just do 3 of you. And now we need a orientation, obviously, so a small inline reaction wheel, a battery. Oh, we need a science. So we need a D-Magic orbital telescope. We only need 1 of those. Let's make this look pretty. I actually wish the telescope was just a little bit bigger, so that it would match the diameters of everything. Oh, that's not going to work. We need to bring it in just a little bit more. There we go. Okay. So that's that. And then it needs to have, so new unmanned probe that has an antenna and can generate power. So it needs an antenna. And it's going to have to be a big antenna because it's going to have to make it back to Kerbin. There we go. And it needs to generate power. So electrical and solar. Here we go. And we need one more on this backside, kind of. There we go. Okay. And then we need to turn this decoupler all the way down to like 3. Yeah, there we go. Okay. Awesome. So that's got orbital telescope, stability for 10 seconds, mystery goo unit. Ooh, good thing we checked because I would have forgotten. And then we would have been in trouble. With a capital T. Right here in Kerbal City. All right. Lucas, I'm still in school, sorry, but I hope to study aerospace engineering and hopefully someday make my own rocket engine. What can I do now to help me be better prepared once I'm in university? Well, obviously, a good background in science and math is important. And so is the ability to be a kinetic thinker, a mechanical thinker. So making things, tinkering, understanding how things are put together and taken apart, very important, as well as building and practicing your foundation in math. And it is practicing. Believe it or not, I'm actually horrible at math, but I had to practice a lot, and so now it's just a fact of life that I do math. All right. Michael Moresi wants me to check my staging, which I think is a pertinent reminder. We'll check that one more time before we launch this thing. Mason Jeffers wants to know an update on the next liquid rocket engine video. Well, I have something to show you. I'm back. And what do I have? I have fully wired solenoid banks. These things are tested and ready to use on the test stand. And I am really excited. So the next liquid rocket engine video is going to be me wiring these and testing these. Like I said, you can see they're already done, so you know that I just have to finish editing the video. And actually, I hired an editor. To help me hopefully make more videos. She did an excellent job with the BE4 engine video I just released. So hopefully I can make more videos now that I am not having to do both the rocket engines and the editing. Not a full-time gig or anything. I pay them as I have content to produce. But it's kind of still exciting because I do enjoy making these videos to show you guys what I'm doing, but I just don't have a lot of time to both make the rocket engines and make the videos. Okay. Let's add some struts. Let's add some struts that connect to the... Yeah, there we go. Okay, good. So that'll help stiffen all that up. All right, let's do one more check on the staging and one more check of the contract. We've got a mystery goo. We have a D-Magic orbital telescope. We have an antenna. It can generate power. We have 2 vessels to rendezvous. We can go to the surface of the Mun. We can get scientific data from the surface of the Mun, and we can plant a flag on the Mun. All right, do we want to bring any other science experiments to the Mun with us? We should probably bring a mystery goo unit, just because that's easy. We can put a magnetometer boom. Let's put a magnetometer boom on the command module just for the heck of it. Yeah, there we go. That's more science. And then on the LEM, we'll put a thermometer and some mystery goo. And I think that's all the experiments. I don't have room for one of these. I can bring a barometer. All right, cool. That'll be good. What are we calling this? Call it Artemis 2? That feels appropriate. All right, staging, check. Michael says, you were planning on going to aerospace or astrospace engineering. Honestly, not a lot of departments have astrospace engineering. It's just called aerospace engineering, so you do you. I think either is equally as good. In fact, mechanical engineering is just as good for getting a job in the aerospace industry. Can I raise the stream volume a bit? Let's see. I think I can. Volume +3. All right. I'll just turn the volume up a little bit. Hopefully that helps. And I'll also move my mic closer. Speaking of new stream gear, check this out. I have a new mic, and it sounds absolutely wonderful. So I'm excited to have this nice new treat. I think it really just does improve the audio quality on all of my work. Okay. Thank you, Benjamin. I am very excited that I have 10,000 subscribers, and hopefully I will have many more before long. Okay, so we've got those engines, and then those engines, followed by decoupling that and firing the escape rocket, or the pusher rockets on that. The next thing I have is the fairing jet, which is correct. Then I stage off that. This is for that spacecraft, and it needs to go in the uppermost stage. That engine, that engine, that engine. All right, so I'll worry about all this once I get actually onto orbit. So I just need to know I have the escape action group set up. If I press action group 1, that will remove the abort system without firing without bringing the capsule with it. And we've got the LEM. It's got landing legs, it's got lights, both things have power generation. Is there anything I'm going to forget? I don't think so. We've got RCS on this so it can do docking and rendezvous. Let's do it. Let us launch this sucker. Here we go. Here we go. Hudson says I don't need parachutes. It's a glitch / Easter egg and you end up with double the science. I've been playing this game since 2011. I was briefly involved with the development of this game. I've been on such esteemed mod teams as the Bobcat Rover team, the ULA Parts Pack team. Back in 2013, I created a Copenhagen Suborbitals mod for this game. So I would maybe not try the it's a hidden Easter egg tactic on me. Just a thought. Benjamin, out of curiosity, do you have a type of engineering degree? I do. I have a degree in aeronautics and astronautics from the Massachusetts Institute of Technology. And with that, here we go in 5, 4, 3, 2, main engine sequence start, and liftoff. We have a liftoff at 29 minutes past the hour as the Artemis 2 mission begins its ascent towards the Mun. And oh boy, that is wobbly. Wobbly with a capital W. But we're just going to fly a standard gravity turn, 90 degrees at 1 kilometer, 70 at 5, kind of tipping over. Paulo, I don't think about graduating really. Probably just finished high school. Oh, okay. Well, gotta keep trying, moving onwards and upwards. What did I do for my first year as an aerospace engineer? Caleb, I worked for a startup called Agile Space Industries, and we build hypergolic thrusters for customers. I think that's what I'm allowed to say. I am not in space yet. Is it any chance for a Norwegian citizen to work for SpaceX? The answer to that is almost certainly. I worked with several Canadians in my time at SpaceX. Hans Königsmann's a German. We had a variety of foreign nationals at SpaceX, but it is definitely more challenging because you have to convince SpaceX to apply for a license for you. So it's unlikely that you would be able to work for SpaceX as your first job. You would have to work for some other job and demonstrate your abilities and then convince SpaceX to sponsor you for an export control exemption. All right, I think this is mostly going to be a fairly straightforward ascent. I wish we had a higher thrust-to-weight ratio on this stage. We'll lose the abort system to save some weight, and I think we'll also lose the fairing. Yeah. Not great. We're not going to have enough delta V to make it into orbit. Entirely because of this abysmal thrust-to-weight ratio. So we're going to go back to the vehicle assembly building. And we're going to do a few things. The first thing we're going to do, we're going to get some struts up in this business. What an idea. And then the second thing we're going to do is we have to fix the TWR on this stage. And the way to do that is going to be by adding these thud engines. That's 100. So this is like a significant increase in the thrust of this vehicle. All right, let's try this one more time. Lucas wants to know, when did I get interested in space and when did I decide to become an aerospace engineer? That is a fascinating question because I first became interested in space when I was about 3 years old. It's one of my very first and earliest memories. T-minus 5, 4, 3, 2, main engine sequence start, liftoff. We have liftoff at 33 minutes past the hour. And notice that our wobbliness is significantly decreased, which is excellent. So we'll start heading up this time. So I started being interested in space at age 3. It's one of my earliest memories was my grandfather taking me to the space museum, and he picked me up and put me on his shoulders so that I could touch the very tip of an SR-71 Blackbird. And I wanted to work on space from that moment onwards. I knew I loved space. But for a while, I thought I wanted to be a space lawyer. So actually, engineering school was just a stop on the road for me before law school. And then, when I was applying to colleges, I'd already picked a college out, and I'd paid my my registration fees and everything to go to this state school. And then I got into MIT. And if you get into MIT, you can't not go. So I canceled my apartment and canceled my registration at this other university, and I went to MIT instead. And the thing about MIT is that it's a lot of work. You might not believe me, but trust me, it is. And so having to do a lot of work, I kind of decided that maybe I was done with school for a while, and I might use this aerospace engineering degree of mine before I went on and did any more schooling. All right. Our ascent is a lot sportier this time. You notice we actually have the Delta V to make orbit this time. We're going to real quick shut these down. Just to get the higher efficiency. There we go. Lakshima Narasimhan V would like to know if I think he can get a job if you've read Rocket Propulsion Elements. I am 100% sure the answer is yes, because you already have a STEM degree. There are lots of people who would love to hire biochemists into the aerospace field because of things like life support systems and whatnot. And I actually think that there's another good example here in the chat. If Joe Barnard is still around, I'm pretty sure his degree is not in aerospace engineering either, and I think he's probably gotten a few job offers from various aerospace companies along the way. Okay. So let's see. So we should be able to stage off that. And then decouple that. Control from here. This is going to be a floating in space docking while falling. Because I'm going to need to use this delta V here to get what on earth? Oh, why are you floating away from me? All right, that's not going to do. Nope, nope, nope. I'm not feeling it. I could try and salvage that, but we're just going to go fix it and fly it right. So we're going to swap these out for solid rocket boosters. There we go. We'll just use those. Put some lids on them. And then what we'll do is we're going to thrust limit these down to like 70% so that they burn out slower. Yeah, there we go. All right, that'll work better. A lot of the aerospace positions you've seen include security clearance requirements. Is this just the norm? Gymnotopic, the answer is kind of yeah. pretty much everywhere. SpaceX doesn't require security clearance, and Boeing Commercial Aviation doesn't require security clearance. But Northrop, absolutely you need a security clearance. Lockheed, absolutely you need a security clearance. Boeing Space, Boeing Defense, absolutely you need a security clearance. All right, let's try this again. Ignition sequence start and liftoff. We have liftoff. Okay. Elliot, what do I think about the new 1.10 parts? More parts are always good. I love new parts, especially parts made in collaboration with ESA. That's really cool. But I'm not playing 110 right now, so I can't have a particularly strong opinion. Blackout, congratulations on grad school. That's a significant achievement. Lucas, my thoughts on SLS. It would probably benefit lots of other programs if it was canceled. We seem to have lost one of our boosters during that staging event. It's like a little missing, which is not great. We may have wanted that. We'll see. We're flying kind of a shallow trajectory again. This design this first stage engine, I think, is causing me more trouble than it's worth. I'm suspecting that probably we're going to be in a mess again. So you know what we're going to do? Did I put parachutes over the hatch? I did put parachutes over the hatch. We're going to transfer Bob into the lab. We're falling. I'm supposed to be good at this game, guys. I'm supposed to know what I'm doing. All right. You know what we're doing? We need more thrust on this first stage. So we're adding an engine. Right there. Yes. All right. So, this has a precedent in history. I'm not just making this up. The Saturn V was actually supposed to be the Saturn IV. Yes, that's right. The Saturn V was supposed to have 4 F1 engines, but it got heavy. And by that, I mean the rocket got fat. The rocket got heavier than it was supposed to, so its thrust was too low. And the engineers came to Werner von Braun and they said, "We need you to add another engine. Our stuff got heavier." And Werner von Braun said, "Yes, I knew you would ask me to add another engine, and I have been planning on adding another engine for 3 years. Look, I have left a spot for it that is exactly the right size, the right shape, and has support beams for it." And so they just added another central F1 engine, and everything was great. All right. What do I recommend doing for the summer to better my chances at a good engineering school? Your GPA is not great because of history and English. You can do the work, you just can't do boring stuff. Well, Michael, I have some bad news for you that I've discovered the hard way, which is that there's a lot of boring stuff in life. And working to get good at doing boring stuff will actually be an invaluable skill for your professional development. But personal projects, maker portfolios are also excellent ways to improve your college prospects, especially for schools that are engineering, like hands-on oriented schools. BPS Space wants to know, what is the longest you would allow your hair to grow, generally speaking? Well, Joe, here's the thing. We are currently in quarantine haircut mode right now. So this is already much longer than I would prefer it to be. But given that the world is a little bit on fire, it's going to continue to get longer until I feel that the long hair is less acceptable than the risk of a haircut. So right now, probably infinite length hair is acceptable because the negative effects of hair would never be greater than the negative effects of possible negative effects of a haircut. Grant Thornton wants to know, any tips on being selected for the job you want and how to stand out? Grant, to be honest, I'm a bad person to ask. I'm very lucky in that I interview well. Abort! I don't know what happened, but bad things, certainly. This will give us a good opportunity to test the parachute system. Yeah, so, yeah, I'm probably a bad person to ask because I'm lucky that I interview very well. I have always managed to be successful on the basis of strong interview skills. And so my professional skills have benefited from that, right? Like, I interviewed well for my first job at SpaceX. So for my second job at SpaceX, I was already, a one-time SpaceX intern. So it was easy to get that job. And then, when I applied for my job at Lincoln and my job at Agile and I interviewed with Blue Origin, I was able to do all of those things off of the basis of my work at SpaceX, which I got off of my basis of my strong interview skills. So definitely practice your interview skills. All right, we're going to try this one more time before I just restart designing that first stage all over again. Michael, you were planning on making a model hybrid engine in your backyard, but you think your parents won't let me. Michael, to be honest, I think your parents are probably fairly smart in this instance. Rocket engines are dangerous. Oh, come on. All right, well, we don't have an abort system because I just fat-fingered the keys, so... we're just going to try again. Wow, I am just not on my game today, guys. I'm just so excited about the 10,000 subscribers that I can't focus on Kerbal Space Program. I blame that. Yeah, so... engines, guidance system. There we go. All right, trying this again. Yeah. So, yeah, rocket engines, especially hybrids, can be dangerous, and I don't think. I mean, if you can do it safely, they're worth it. But if there's any doubts or any questions, especially if you don't have a mentor, probably not worth the risk. I promise you can do a lot more if you wait a year or you go to community college and spend 2 years, proving yourself at a community college before you go to a 4-year school. You'll do a lot more delaying yourself by 2 years than you will, trying to recover from a lost finger or two. Wow. Okay. So we need to get, we need to do something about that staging system because that seems to be deleterious to one of those side boosters. All right, well, we lost those now. So I think this is going to be a lot easier because our TWR is plenty high. So the odds of this working are a lot better. So we'll lose that. We'll lose that. Yeah, now we're just chilling our way up to orbit. This is a lot easier. That central, that like, 20% thrust made a big difference. Benjamin, would I consider being a YouTuber full-time? Probably not. I really enjoy my job as a rocket scientist, and I hope to use my credibility as a rocket scientist to boost my ability to communicate on YouTube. Which is to say that I view my work on YouTube as an opportunity to communicate about the cool work I do professionally, rather than viewing my professional job as a income stepping stone on my road to being a full-time science communicator. Maybe if I did shows for Discovery Channel or something, I would be more interested in doing full-time science communication, but I don't think I would just do it on YouTube. Yep, Porky, we're headed to the Mun. I mean, we would be if I ever figured out how this first stage worked. After being initially optimistic, I'm now somewhat skeptical again. Yeah, Michael. I mean, certainly there's varying degrees of danger, and model rockets can be done fairly safely. You just have to try and find something interesting and compelling about. But it is true that going to parties and saying that I'm a rocket scientist has its own appeal. It's not nearly as great as you think. Because most of my parties are with other rocket scientists. But if for the rare occasions where I go to non-rocket scientist parties, it's pretty great. Okay, so we've got that. So let's see what our apogee is. It's 60 some kilometers. And we don't need a whole lot. Actually, it'll be so inefficient. So let's not do that. So let's stage this. Decouple. And then let's move a Kerbinaut down to there. And then we'll point it this way. And then we'll decouple that. And then we'll flip back here. Oh, does not have operational SAS and no pilots. That's not great. All right, so let's lose this. Point you around. And we're going to dock the other one to this one. There's certainly a little bit of drama here. Someone play the Interstellar theme from the No Time for Caution theme from Interstellar. I'm 100% sure I will get copyright struck if I try and play it, but it's highly relevant. That didn't work. Trying that again. Woo! All right. Focusing this time, paying attention. Goodness gracious. We're falling. We are falling. We are falling. Hello. Woohoo. Any second. Oh, come on. I can't even push the right button, guys. Trying again. Well, the landing gear works. We've established that. I don't know. All right, we're going to try this again, but we're just going to go back and fix the problems. Ugh, guys, what am I even doing? I'm supposed to be better than this. I'm so sorry. All right, step one. We're going to add some propellant to these side boosters. All right. That's going to give us a few more seconds of burn on this at that high thrust level. Next thing we're going to do, we're going to add more boosters, because everyone knows the secret to maintaining your dignity in this game when you fail repeatedly is to blame the number of boosters and not your piloting skills. So, we're going to add some of these hammers. And we're going to take these, and we're going to turn their thrust down so that they burn out second. So we'll light them all at the same time. And then these go, and then these go, and then these go. All right. Improvements. Now we know we need to add a a reaction wheel module to the lunar map module. So the module we're going to add is... Does this have reaction wheels? I need it to have reaction wheels. Yes, this does have reaction wheels. Going to add this... let's see. I need just like a little attachment node. What's a good part for an attachment node? Not that. That is too big. How about this? Also too big. Not a fan. Nope, not that either. I just need... That's heavy. Maybe one of these is surface attach. Oh, you know what I'll do? I'll do a fuel tank which has surface attach. Yeah, here we go. All right, so fuel tank with surface attach. And then we'll add inline reaction wheel. And then we'll add a probe core. And then we'll take this whole thing and we'll slide it down into the middle of the spacecraft. There we go. All right. Excellent. That will have fixed a lot of problems. All right, trying one more time. Nothing could possibly go wrong. I don't know why you would believe me saying that after everything you've just watched, but I promise you, this is going to be the time it works, right here. And to ensure that my mind is sharp and focused, I have taken another swig of beer, which will improve my performance immediately. So we've got the engines working, we've got the guidance up at speed here. We've got our 3 intrepid Kerbinauts on board. Let's launch this. Here we go. Upsy-daisy. Flying upwards. So these are about to deplete, and then these will be next. Burnout, shutdown, release. Oh, all right. Well, we got rid of the big solid rocket boosters earlier than planned. All right. That was fuel I maybe would have liked to have kept. I wonder if it helped or hurt to even have those little boosters on since they killed the big boosters early. Grant, I like this Blue Moon. There's a really, really excellent Sam Adams cherry wheat ale that I like. What else? Stella Artois. Excellent beer. There's a local brewery here called Ska Brewing Company that has some microbrews that are really tasty, but for the life of me, I couldn't tell you what they're called. I just have them in kind of unlabeled cans, and they're always fun to go pick one out of. All right, booster burnout, so we can jettison those. And then we can get rid of the escape system because we don't need it anymore. And then we can get rid of those panels. Ooh, all right. Well, my poster just fell down, but that's okay. Yeah, I was kind of getting there's Apollo vibes up here and steroids vibes down here. You know, kind of Apollo in the front, Soyuz in the back going on. All right. We may have been a little shallow on this ascent. What's my apoapsis? 70 kilometers. All right, we've got a few seconds of propellant left. We've got 100 meters a second of propellant left. That's not nearly enough to circularize, but what we can do now is we can do the trick that I tried to pull last time, but it'll be a lot easier. So we can transfer you to there, decouple you, flip back to you, hit the guidance, flip back to you, thrust positive, turn the RCS off, flip around. See what happens when I'm paying attention, guys? I do what I'm supposed to do, and then we can decouple you. There we go. We can set you as target. RCS, thrust positive. And we can get you nice and centered. And this should be absolutely no trouble at all. Check this out. Oh man, so easy. It's like cheating. And docked. See how easy that was, guys? Look, all you gotta do is not be a scrub like me. So we can decouple this now. Oh, well, that was dumb. There was 116 meters a second of propellant left in that. That's okay. We can do just fine without it. We can activate this engine. Point it this way. And throttle up. Now, where's the MUN? In the worst place possible. So we'll just circularize here and then figure out how to get to the MUN. All right, we are almost going to be in orbit here. Periapsis at 30 kilometers, at 50 kilometers, 70 kilometers, 100 kilometers. Awesome. That's actually a pretty good orbit. Not bad at all. So now we're going to set target. Yep, there we go. And add a maneuver node. There we go. 800 meters a second. This delta V budget is going to be a little on the tight side. The extra 100 meters a second from that from the ascent stage would have been really nice right about now. Oh, look at how good that looks, guys. Holy cow. The clouds and the flare from Kerbal. Oh, man. This game is just really pretty sometimes. All right, 15 minutes till our translunar injection burn. Sorry, translunar injection burn. There we go. We'll start our burn now. Michael, I don't know if the college admissions people usually know what Kerbal Space Program is. It's really kind of a big thing in aerospace, but a lot of the colleges don't have department-specific admissions officers. Which is to say that you get admitted to the school, not to the Department of Aerospace Engineering. All right. And coming up on shutdown. There we go. We are going to be just the tiniest bit tight on fuel, and by just the tiniest bit, I mean like pretty tight. We may not be deploying. How much propellant does the satellite have? It has really quite a lot. I think we can do. We're going to separate this off now. And like the worst case scenario is we just have to launch another one of these. So totally fine. And we're in eclipse now, so we will time warp until we are out of eclipse. All right, so now we need to plot a maneuver node for this tiny spacecraft. So we need to go up over the Mun. We need to get there a little sooner. Get the inclination right. The inclination is going to be the most expensive thing to fix, so we want to get that dang on. Okay, there we go. So this is going to be, so what we'll do is we'll start circularizing the orbit right there. And hopefully we have enough monopropellant to do that. So that burn is in 3 minutes, so we can just go ahead and do that now. No problem. We'll turn on caps lock, RCS. Oh, we're not going to have enough delta V for this. Nope, no way. It was a nice thought. Nice thought, but no way on Earth that's going to work. That's okay. We'll try again with another spacecraft, and we'll just get some data as we fly by the Mun. Now we need to switch back to the other spacecraft. Hi, please cooperate. The Sun, maneuver 1. Switch 2. Okay. So this one we need to get in as low of an orbit as possible. So this one is currently arriving at the Mun. And then getting accelerated out of the lunar sphere of influence. So what we want to do is we want to arrive at the Moon. I think we want to arrive a little sooner. Yeah, so that pulls our periapsis in lower. We can survive like 14 kilometers. We are now fighting for delta V here. 5 kilometers. All right, we'll be bold and try 5 kilometers. It is entirely feasible that this could end horribly. Okay, so we got that. And we should have plenty of RCS available on this vehicle. We're going to lock down that monopropellant so we use it off of the CSM. All right, here we go. Monopropellant only thrust. Maybe that was a mistake. All right. Just kidding, we're using the engines. Too low. That's better. All right. Now we have an intercept trajectory for this one. Michael, you want to know if MIT is just a bunch of smart, cultured people? No, no, it's really not. MIT is all kinds of people. There are football players and cheerleaders and basketball stars and chess masters and Rubik's Cube solvers and people whose entire joy in life is drinking boba tea. There's a lot of boba tea drinking at MIT. Um, so yeah, I mean, I don't think that there's any one size fits all kind of thing, and I don't think you can guarantee that anyone knows any specific thing or another. Um, let's see, what is next? Is the M drive possible? I'm gonna go with probably not. I would love it if it were possible, but it doesn't seem likely that it works. What was the toughest course throughout my undergraduate career? Definitely Unified Engineering. It was a 24 credit, 2 semester long class that was really, really hard. Also, you had to wake up at 8 in the morning for it, so that was probably the roughest bit. Depredum wants to know what was my Deba Pratim. Deba Pratim wants to know what my job was at SpaceX. I was a launch engineer for 5 months and then a manufacturing engineer for 5 months. The launch engineering position was at Cape Canaveral, Florida, at Pad 39 and Pad 40, and the manufacturing engineering position was in the tower at Hawthorne, which was really cool. Thank you, Guerra. Have a wonderful evening. All right, let's see. So we want to time warp till we get to the Mun, and the crew spacecraft is going to get here first. So we will track it. Actually, that may not be the case. Yeah, it's going to be this one. Okay. So this one is going to not work, but that's okay. We'll try it anyway. We will aim camera. Toggle shutter, log visual observations. Can this not, is this not taking science? How can I get science off of this device? Nope. None of these things. Okay, maybe you just don't get science off of this device. Reset camera. Log visual observations. Here we go. Yeah, okay. No science. Never mind. That's worth no science. I must have already done it. Observe mystery goo. That's worth some science. We'll transmit that. Transmit data. Cool. We also missed a little on the inclination for this spacecraft, which is especially bad because of how little delta V it has. But we'll give it a try. We have 12 units of monopropellant to make it into orbit, which is improbable, to say the least. And by improbable, I mean likely impossible. 4, 3, 2, 1. Are we in orbit? Oh, we are in orbit. We aren't going to make it into the desired orbit, unfortunately, but that could have been worse. I would not have had to have been a lot more efficient with this spacecraft in order to make this work. Aw, that's disappointing. Reach the designated orbit. We are like almost here. This is frustrating. If I'd just been a little better. See you, Andy. Thanks for dropping by. If I'd been just a little better at flying this particular spacecraft, this would have been a success. Well, we're off by 5 degrees on the inclination. That's not super helpful. That's us out. Okay. Well, we almost were useful with this spacecraft, but unfortunately we missed. So we will rename vessel into debris and say we tried. On the other hand, we can hit the brakes on. All right. There we go. We are now in a lunar orbit of some description. We will fly out to apoapsis. So I think we should have plenty of delta V on the landing stage. So we will transfer Jeb to the thing here, and Bob is the scientist, yeah. So we've got Jeb and Bob in the lunar module, and Bill, the engineer, is going to stay up here in orbit with the CSM. So we're going to undock you and take this opportunity to figure out what we've got going on here. We need the monopropellant. Okay, so what do we got going on? We have 1,300 meters a second in this landing stage, which is so much extra. All right, we are just fine. All right, no worries. We've got plenty of delta V on this. Caleb wants to know if Embry-Riddle Aeronautical University is a good college, to which the answer, I would say, unequivocally, is yes. They're a great college. Okay, let's figure out. So we need to go to apogee. No, we don't. We can just go straight down to perigee. So we'll save here. And of course, we're on the dark side of the moon instead of something smart. You know what I will do is I will swap to you real quick, and I want to raise this guy's orbit so it doesn't crash and die, which would be bad. 6,000, 7,000, 8,000, 12,000. There we go. We need to turn on the comms link in order to get delta V information, I think. While we're doing this, we can extend the magnetometer boom. Yeah, there we go. Not useful. All right, well, we tried. Crew observations. Also not useful. All right, well, we tried. No, there's no science to be gotten from that whatsoever. Switch to. All right. So, we should just be responsible for falling now. How close are we going to get here? Close. So we are going to crash. So we have to start braking now. I'm sorry, I said start braking now. Thank you, Casey. Welcome to the stream. I haven't seen you here before. Clovers are always appreciated. They're very necessary. So we're currently on a collision course with the surface of the Mun. We're trying to fix that by starting our braking burn a little early. Oh wow, isn't that so pretty against the limb of the Milky Way? Oh, that's just spectacular. Let's go ahead and get the landing gear out. All 6 landing legs. Not exactly historically accurate, but it looks good. How are we doing? All right, so our apogee's at about 11 kilometers, which is fine. Let's check a crew report. No information there. So we're gonna try this. This reminds me a lot of the crater that Curiosity's at on Mars, Mount Sharp and Gale Crater. But we'll land kind of in this flat area right here. All right. Slam on the brakes a little harder because it looks like we're about to overshoot. Yeah, there's so much spare fuel on this thing, it's not even funny. We could have been a lot less efficient with this descent and still been just fine. All right, so we've got retrograde on, we've got the lights on. Now it's just a matter of falling with style. Kanchan Mishira wants to know if I see India going to the moon, and the answer is certainly. They already had an almost successful mission last year with the Chandrayaan 2 probe, and they had already expressed interest about trying again, so I expect they will try again, and I expect they will be successful on their next go. $30 meters a second, 400 meters AGL, 200 meters AGL, 200 down by 20, 150 down by 20, 100 down by 5, 70 down by 7, 30 down by 9, and contact light. Oh, crap. Sticky keys tried to turn on. There we go. Hey! All right. Well, that is an actually significant success for me this evening because, holy cow, I have just not been on my A game today. But look, we didn't even bump the nozzle, which, as far as I'm concerned, is a huge win. So let's get a crew report. Worth 20 science. Let's get Jeb out on EVA. And the very first thing we have to do is we have to plant a flag so we get that contract fulfilled. Flag planted. Dun 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 dun. And this is going to be the 10K landing site. In memoriam of the 10,000 super cool Rocketeers who waste time watching me build rocket engines. Yay! All right. But now we need to get a surface sample. Lots of science there. And EVA report. We'll keep that experiment. And Let's get back in. Well, that was successful. Let's try that again. There we go. All right. So we have 400 meters a second left of delta V on this thing. That actually might be enough to try landing somewhere else. Just in case, we're going to observe the mystery goo. Log temperature and log pressure. And we're going to get Bob out, because it wouldn't be fair to not to let him have a turn on the lunar surface. His dismount there was very graceful. Casey, yeah, if they were subscribing to me, they must have been kicking the bucket, right? I can't figure out how else they managed to click the button by accident. I'm sure there's a marketing class that says insulting your subscribers for subscribing to your channel isn't good business practice, but I maintain that there's not much entertainment value in watching me hack together cheap parts into rocket engines. Collect data from that, and we'll restore it while we're here. Awesome. Well, welcome to the Streamwisest channel. I'm glad you're still alive. All right. So let's see. Let's get back in here. While we're here, we'll extend that antenna. So what's the gig? So we can go, if we go east, we can land in the daylight. We want to try and get in a different biome. That's a different biome right there. Oh, that's far away. Okay, so you know what we might do? We're just going to chill on the surface here till it's daylight. Yeah, that's what we're going to do. Okay, so now that we've chilled on the surface till it's daylight, now we're getting power, which is good. So now the goal is to get out of this crater, and it looks like the easy way to do that is going to go back the way we came, so we need to go west. So west is that way. We have 400 meters a second, which means we can use 150 on the way up. So we will hit that F5 button, and here we go for our sideways hop in 3, 2, 1. And shut down. That is not nearly as far as I'd hoped it would be. We're not going to have enough to land. I mean, we might. Oh, boy. It's going to be tight, folks. In theory, we have enough delta V to land. In theory. It's going to be real tight, folks. I used up like 44% of our delta V, so we have 6% margin. Okay, so we're decelerating at 9.7 meters a second with our engine at full thrust. We'll be falling at roughly 200 meters a second when we get to the ground. So 20 seconds above the ground, we need to be slamming on the brakes. The question is, where is 20 seconds above the ground? That's the ground there in 12 minutes and 57 seconds. So we're going to add a maneuver node. And when we are 20 seconds away from this maneuver node, we'll know to be slamming on the brakes. That can't be right. Yeah, that maneuver node's not right. Oh, because that's where we came from, not where we're going. Oh, we're, yikes. Okay, brakes, 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 brakes. Ah, ah. Oh, it's gonna be close. It's gonna be close. Woo-hoo-hoo! 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 7 meters a second. Ladies and gentlemen, that is how you do that. Efficiency, not a drop of wasted hydrazine in those tanks. Okay. Doc O wants to know if I have any plans to photograph Jupiter or Saturn through my telescope. Well, Doc, let me see if I can pull up something for you. I have been somewhat of an astrophotography nerd for a long time. I got my first telescope in 2009, and I got my good telescope in 2015. So let's see. Imager. I think I can pull up a picture I took through my telescope. Nope, not that one. Weird. No? About? I would expect that I have my images available. Okay, that's weird. For some reason, it does not appear to be available right now, but I've taken some really cool pictures of Jupiter the last time I was at opposition. I would love to show them, but I apparently do not have the ability to do that right now. Okay, so we're on the Mun. Let's see if we have landed in a new place from the Mun's east crater. I think we're still in the same... Let's see. Review stored data. Ah! We're still in the east crater. All right, guys, we tried. We just didn't quite make it far enough. We need to be there, but we're there. That's okay. This is fine. We will wait till the Mun rotates, and then we will launch up to our waiting spacecraft in orbit. There we go. So we need to be launched to the east. So let's make sure everything's all set. I think it is. Yeah, okay, I think it is. So we should just be able to... Oh, we're out of electric charge. That's not great. Does this engine have an alternator? Not great. That didn't get me any electric charge. Okay, no electric charge. Guess we'll wait till the far side. You know, we have plenty of delta V on this spacecraft, so we can afford to do an inclination change. Yeah, all right. Yeah, let's just get started here. Here we go. Up's a daisy. And we're going west. We're going northwest. Nope, we're going east. Holy cow, that was bad. That was scary. Good thing we have lots of extra propellant. Yeah, here we go. This will be fine. So we just need to make it into orbit, and this other spacecraft can kind of come grab us. Set as target. I forgot that the reaction wheels were on the other stage, so we only have RCS on this. Yeah, all right, there we go. So we'll do that maneuver, then we'll do go the rest of the way with the other spacecraft. Oh, well, we just blew right past our node. That's okay. We'll run it anyway. All right, there we go. So we're going to come up here to the ascending node, and we're going to fix our inclination with this spacecraft using RCS. But not in any of those ways. Never mind, we're not going to do that. Huh, okay, how much delta V does this spacecraft have? This is not looking, let's see. We have, who knows how much delta V? We have some amount. And no... Add a maneuver. All right, that's a decent maneuver there. It's 200 meters a second, which will be a lot of what we have left. But then I think we can do the rest of it with the other spacecraft. So that's 3 hours. Here we go. 20 minutes. 10 minutes. All right, stand by for main engine start. To begin our orbital alignment burn. Ladies and gents, this is going to be a tricky one. All right, so TWR of about 1. So we need to start this burn at about 10 seconds. And 3, 2, 1, ignition. And shut down. That's not bad. That's not bad. You know what? Not bad. I think we can live with that. All right. Checking the chat. Let's see. Keep up the interesting videos. Thank you, Andrew. Ian Ross, when worst comes to worst, just kill a Kerbal and let them decompose until it's a bunch of methane gas. No, that's definitely the worst. We won't be doing that. That is a bad idea. Lucas, thank you for joining us. I stream Kerbal Space Program sometimes. I try to do it more regularly than I do, but usually it ends up being about once a month. Let's see, set as target. No, I want to switch to. And then I want to set this one as the target. Set that one as target. Yeah, there we go. Okay. So I am in a lower orbit, and I'm trailing them, so I'm catching up. So if I add a maneuver... Okay, that's not what I want. Add a maneuver. All right, so I want to be like getting as close to circular with them as I can. And let's see. Intersection. What's the deal here? So I'm going to be... The target is ahead of me, so I want to stay in a lower orbit. How much modern propellant do I have left? So we want the target to do a slight burn at apoapsis. So we want to switch back to the Artemis 3 capsule. So because the higher spacecraft goes slower, we want this spacecraft to become the higher spacecraft again, so that this one down here can catch up. So we're going to get to apoapsis, so we're just going to do a little burn. Just to kind of... Not that way. We need to go this way. Oh, nope. Come on. $14 kilometers, 7, 4, 3, 2. Yeah, 2 will do. All right. We've got 7 units of monopropellant on this one. Oh, this is just tight 6 ways to Friday. Thank you for stopping by, Lucas. Oh, boy. All right. Well, we want to be in this one. And this is going to have to be an efficient docking. We will quick save real fast. Periapsis of 20 kilometers. Good news, we aren't about to crash into anything. Let's see, a minute. All right. So now what we want to do is we want to get turned around a little bit. So we're at relative velocity negative. And at relative velocity negative, we can use our RCS to kill our relative velocity. And then we can point target positive. We don't have many units of RCS left. One 1.7, 1.6, 1.4. $600, $500. Here we go. $400, $300. All right, so what we want to do is we want to switch to this one, and we want to point at 180 degrees. Like that. Switch to this one. And oh boy, this is going to be tight. Oh, no, no. No, no. We can calm down on that. Nope, bad. Darn it. Fudge. All right, we're out of RCS on this one, so we're going to have to finish the rendezvous with the other one. Sorry, I'm concentrating here because I've done this on the tight side. Nope. All right, whatever. You know what? We can fix this another way. Check this out. We are really struggling here. Oh, you know what? I bet the hatch is blocked. Yeah, get some on Simber in here. True story. Well, hello from Germany. Thank you for joining us, Eno. I bet you it's blocked. Oh, no, it's not. All right. That's probably an exploit, but you know what? It saves the mission, so you know what? We are okay with this. EVA, please. All right. Not the most stressful docking of the mission. We have some quantity of fuel left. Let's see how this goes. Add a maneuver. We need a few hundred meters a second. Okay, so that's really about what we need. We need 200 some. I don't know if we're going to get 270, but we're going to try. If I were NASA right now, I would have the astronauts go on EVA and like start like cutting stuff off the spacecraft because it's going to be tight. I think we'll make it. I think we've got 270 meters a second of delta V on the spacecraft. I don't know why it says we have none. Maybe it's because this stage is above that stage. Yeah, there we go. We've got 1,400 meters a second of delta V. Oh, why was I worried? Okay, you know what? Never mind. We're fine. Situation totally fine. We burn in an hour. Then we get to go home. And then we can put a bow on this stream with a very successful moon mission. Actually, let's see how our contracts... None of our contracts popped up and said, like, contract complete. It did not give us credit for this. Oh, because we never killed the relative velocities. Okay, so that's kind of not great. Bring a vessel that landed on the Mun back to the surface of Kerbin. Okay, so we are going to achieve neither of those two goals because we aren't bringing back the vessel that landed on the surface, and we never killed the relative velocities. So I guess we have to come back with another Mun mission to get those contracts. But that's okay. That gives us an excuse to bring the satellite as well. Although we should have just left the satellite on the spacecraft. We would have had plenty of delta V to use this spacecraft to get it into that polar parking orbit and then land. So really, my fear for the amount of delta V in this spacecraft is what led to the poor mission planning here, because I could have used this to circularize in a lower orbit that would have been much easier for the ascent module to get back to, much easier for it to rendezvous with. This whole thing just could have been a lot easier. But hey, that's okay. We aren't here to go the easiest route. We're here to watch me make stupid mistakes and be funny. We'll target like 40 kilometers. 37? Yeah, 37. Okay, there we go. F5, just for giggles. Hit that retrograde. Slam on the brakes a little. And we'll stage off. Uh-oh. This is not good. Hello, I would like to detach, please. Thank you. There we go. All right. There we go. Back to normal. The other thing we should have done is we have so much ablator in this heat shield. We could have saved a ton of mass by reducing that. But it didn't end up mattering. We used a little bit of it, and everything's fine. All right. We are just about through this mission. We'll pop some parachutes and get this thing on the ground. Ooh, Edo-san, you're right. I have not seen that comet. I will have to get my telescope out and try and get some good pictures of it. Actually, my telescope may have too high of a focal length. I may just need to put my camera on a tripod. But I have not seen the comet yet, so I totally should. All right, all the parachutes. I think that's, yeah, there we go. 9.4 meters a second. Well, this was a catastrophe of an attempted MUN mission. But the astronauts all survived. Everyone is alive and in one piece. So you know what? We will recover this mission and declare it a success. And next time we'll try and fly a better job. It was highly productive with 294.7 science. We got essentially no parts back. But the crew got some experience, which is good. That'll let us do more cool stuff. We've got 300 science to spend. What do we want to get? Miniaturization, that gives us the mini docking port. I don't actually care about any of the airplane parts. This gives antenna parts. This gives advanced electrical systems. This is worth spending the points on, probably. Oh, but you know, we're going to want this. We can get rocket propulsion, which gives us Werner engines, the Twitch, the Spider, the Puff. None of these parts are useful. Or we can get heavier rocketry, which gives us the service module, the mainsail liquid rocket engine, the Bohr, this thoroughbred solid fuel booster, the Cheetah, Skiff, and the Kodiak. Okay, this is a no-brainer. The only correct answer is to take heavier rocketry. Yeah, take care, Casey. Thanks for dropping by. And with that, I think, actually, we will be done as well. We've spent all of our science from that incredibly successful mission, and our Kerbinauts are now recuperating after their stressful 13 days in space. So thank you all for watching, and I will see you on the next Kerbal Space Program livestream or in the next episode of Liquid and or Solid Rocket Motors. So thank you very much for dropping by, and once again, thank you so much for 10,000 subscribers, and I cannot wait to share all of my rocket projects with you and hopefully many more excited Rocketeers. Have a wonderful evening. Bye-bye.